Welcome to AudaxCeph 3 introduction presentation. In previous versions, AudaxCeph challenged the computerized cephalometry paradigm with the introduction of the technology components for fully opened and customizable cephalometric analysis software. Three products were introduced: diagnostic environment for cephalometric analysis, diagnostic environment for cephalometric superimpositions, and last but not least, cephalometric analysis type modeler. In version 3, AudaxCeph is given additional three products: orthodontic photography manager, visual treatment objective simulator, and document management. So this is the environment, and it resembles very much on Microsoft product Outlook, and we'll see in short time how it works. First, I'm going to add a new patient, and I go here. There are several options. I can do it from file or simply add it through the form, and the patient name is going to be Anna Gray. She was born on the 1st of July 91, and she's a female. Now I'm going to save it to a database, and here she's 22 years old. We can notice that stage was created on today's visit date, so 31st of July 2013, and we can add some documents to that stage. All the documents are arranged by stages, so I'm going to open a folder and drag and drop a document inside that very first initial stage. System automatically asks me whether this is lateral X-ray image, lateral face, no smile, or the image should be undefined, and I'm going to choose lateral X-ray. So let's confirm that, and the document is added. Now I would like to do a new analysis. I can either choose that new analysis from context menu drop down, or evolve. So I can push that evolve button and put those points on the screen, on the canvas. Now you can notice that all the geometry is bounded with a mannequin, and now I'm going to move that mannequin and place those points very close to the location where they should be. All the geometry is in one color, it's gray. When I move the point, it becomes in another color. What is really cool is that I don't need to grab the point itself. I just grab the name. I grab the name, and I can put those points to appropriate places. Order of placement is not important. It's just the fact that it should be placed on the right position, and it's very easy to navigate. You can see all the points. When I click a point, for example Gnation, the image will change, and it will tell me something about the point. Now Pogonion, then I have here Pogonion, then I have lower lip, then I have here stomion, upper and lower, and I'm placing those points very quickly. I can navigate through the image just by moving around, and it's really easy to do it. Now this has no color changed, so I'm going to place it here. Now I'm going to switch on the report layer, and on the report layer it's usually something that I want to have on the report. So perhaps I don't need that for creating analysis, but I need this for creating reports. I want this to be on the report. You can notice that not all the geometry is as it should be. So I simply take some geometry. I can say, okay, let's add some points, or perhaps here I'm going to put this one here, add a point here, and do this movement. Now let's continue here. And perhaps add some points here. So it is really a nice chin here. Now when the analysis is done, I can check whether it's calibrated, because we have a green sign here. It is calibrated, and I'm done with the analysis. I can create a print. So here I can create a print, or I can I'll make it a bit smaller to fit inside the window. Otherwise it is full screen, and I can even choose between different kind of reports. So it could be one page, something like this, or other ones. Now I'm going to save this analysis, and it's been saved to our document system here, and you can note here thumbnail, and here is something like additional documents to this analysis document. So I have here a report. I have here some layers exported. So if I double click it, it will be seen in a viewer. I can make a copy to clipboard, start a Word, for example this, and paste the document inside the Word. I can do that same thing with other documents. For example, I can copy to clipboard this vector image, and it's here. Because it is a vector image, it is really nice to print it. It will be unblurred, it will be smooth, and I can place it in my report in any way I want. So it's really nice for creating presentations and for creating a demonstration to the patient, or perhaps to prepare an offer for him. Okay, now I'm going back to analysis. The main challenge with this software is that we can create, because of the modeler that is built inside, any analysis type imaginable. So we can create a geometry, we can create measurements, we can do everything. Now I'm going to show you how. So I'm going to go to design. So what is behind? I would like to show you that awesome technology that we have here. I'm going to create a point here, and another point here, and another point here, and then I'm going to create a plane between these 2 points, and then I'm going to create a parallel plane to this one going through this point. Now you can see that if I select this plane, I cannot move it. I cannot do any movement. But if I change the position of the point, because this plane should be parallel to the first one, it will always remain parallel, and it will go through the point that I selected it to go through. So I have here a mechanism which behaves according to my design intent. Now I created another plane, and I'm going to make a point on the cross section of last 2 points, and if I move that first point around, you can see that the cross-section point will always remain on the cross-section, even outside of the plane, because it goes very far, you know. Now if I create a distance from this point to this point and angle measurement from here to here, or perhaps I want this one, and make a movement, you can see that the distance is changing here and the angle is changing here. So you can think about how it works with these elements that are available here in the list. So we have points on plane, convergence points, different type of planes, arcs, silhouettes, and so on. We can create a geometry which is able to act predictably, and you can see how a demo analysis is created. Now I'm going to move one element around, for example Nasion, and all the geometry is moving accordingly. So I can again move that around and everything moves as expected. I can hide some elements, for example this, and this is something that's going to be printed, or I can simply save this analysis to my documents. Now the second thing that I would like to show is perhaps we are going to make a treatment to that patient, and we want to have a simulation, and we want to show that simulation to the patient. I'm going to create out of this analysis treatment simulation, and I'm going to VTO module. And VTO means that I have predefined cuts here. I can move incisors, I can move parts of maxilla and of mandible, chin, and so on. I just grab it and I select a new position, for example something like this, and perhaps I'm going to move these teeth into that direction, or to rotate it a little bit and place it back, and so on. And you can see how geometry changes because of different techniques in during the operation or during the surgery. We can change also the predicted tissue and make prediction according to our knowledge, according to our operating technique. And now I would like to see what the movements are, and there are two different ways, either to put measurements or simply to show some delta boxes, for example this one. So I can double click on that. I have delta x, y, and I can also do some rotation through the dialog box as well, or reset it back to 0. So I can prepare such cases. And one thing is also, as I said, I can do for example measurement from here to here, or I can create some angle measurements, for example from this to this, so it's 07 something. And when I am done with that, I can switch off delta boxes. I can go through different presentations, how it will be after treatment. So VTO tissue, is there. So prediction is there is no image prediction, and what we would like to have here is we would like to put an image on top of the surgery simulation and see what happens. So let's put an image. We don't have one, so let's add one in documents. Here should be another image. I'm going to open it here and place this image inside. So when going to prediction, here I have that image, and I'm going to place the point of rotation to tip of nose, put the tip of nose here into this position, and simply make this image a little bit smaller so that it fits to the profile. Now I'm going to finish that, and you can notice that this is going to be the end position, and let us do the calculation. And the system calculates a new image, so this will be a new profile of that patient. We can also see on the VTO3 this was how the patient looked before, and this is how she will look after the treatment. One additional module that we have here is also for storing orthodontic photographies, and with this document we can see that we already have one lateral face no smile image, we have lateral x-ray here, and we would like to add several other elements. For example, these images we took photography of a patient, and we will put that inside the system. So these images that were already put are shown here in a preview. They don't have any definition what kind of images they are, so I can open them in a module for managing orthodontic photographies, and these are all undefined images. Now I'm going to choose a tool where I can place those images so that I will assign a certain type to them. So this is upper arc, and I'll put upper arc here. Then I have lower arc, I'll put it here. Then I have occlusion from side, for right side, occlusion for left side, frontal occlusion, and I have two more images. This is frontal face no smile, and this is frontal face with smile. Now when I finish that, I can notice here that there are no undefined images. If I go to all images here, I can see that all the images are ticked, so they have tick, so all the images are given certain type. Now because of this, and when I have a predefined layouts, they are automatically placed into a predefined layout. What I can see here is that this image is looks smaller than this one. That is because the layout was created according to photographic standards, and this image has no photographic standard inside. It's a bit different aspect. What I'm going to do now is I'm going to change it a little bit and make it a little bit smaller. So it will be something like this, and it will be placed inside. What we can notice now is that this image is much smaller. The patient on this image is much smaller than this one, and I would like to align to that. And now I have a tool here where I place here, and chin, and top of the head, and I'm going to center it a little bit, and it is here, and I'm going to align this one to the first again, She's smiling right now. Okay, looks nice. And then we'll save it. When I'm happy, I can put this to save this to stage. And if I look this at documents, I can see that it is already there, and all those images are here on this photography. Of course, this can be put to the clipboard. I can copy that to the clipboard. It is really high resolution, and if I open Word again, I can place it to Word, and it's there. I can put that again to PowerPoint or to any other document. So it's put to clipboard. It can be put to clipboard or print it or whatever. I can compare different types of images, I mean the same type of images between several stages, so that I can see the progress and can make customized layouts. I have here a template editor and so on. So we can really create very nice presentations, and inside this also use the results of our treatment or treatment plan or whatever. So this is, for example, a preview of an image. This is a preview of a VTO, and so on. Now I'm done with that patient. I'm going to go to superimposition. I have here another patient who already has some different analysis. Oh, it's all there. I'm going to delete something so that it will not, for the presentation, it will be easier for us to do. One thing, how to do superimposition, it's very simple. So this is analysis which was done 3 years and 4 months later than the first visit. So I just drag and drop that over, and it will create a superimposition. Actually, it will create several superimpositions and create several documents which are created automatically, and it will save me really a lot of time. So if I pick this superimposition, you can see here is the preview of the superimposition. Here is some report that I have. Because of the color, print color is white here, you cannot see the elements, but we can choose any color we want. So for example, if I open that, it will be here, so it's white. I can go to superimposition and say, okay, fine, I don't want white color, I want to have green color, and I would like to save it, and a new situation is saved into the system. We also got new documents. You can see because I changed the color, this image changes and also exports change. So it's nothing wrong with that. Now, what we can do also is create structural superimposition. That means superimposition according to stable structures. For example, if we want to superimpose both cranial bases, we can use Walker points and the bottom of the cranial base. Of course, we need to do the tracing in advance. What I would just like to show now is superimposition and how it works. So I'm going to define a new link, Okay, a link, add a new link. It is going to be a point and rotation link, and we'll define elements, walker point here, walker point here, use calibration, assemble that together, and what we can see is I would like to position this on top of this cranial base. So what I do is I simply place this one on top of the other. Walker points are aligned, so this is how this superimposition will look like. So now I'm going to press done, and we are done with the superimposing. In this way we can superimpose cranial base, we can do superimpositions in region of mandible and maxilla. What we need to know is just we have to trace certain stable structures and do that. We can even create measurements between points. So I can go here to design and make a distance between, for example, this point and this point, and this is the distance is 5.18 millimeters. I can use a delta box, for example, for this one, for the same point. It's 5.1, 1 and 5.2, approximately 5.2 for these two elements. So if we want to see what is the displacement, it can be created. Now we can measure angle here between, for example, 2.55 millimeters and so on. So it's really a lot of things can be done. We can copy elements so that that we can compare, for example, different lines with different superimpositions between each other. Now I have here, for example, this is sella nasion. This is the displacement. Then I have anterior nasal spine, nasal line, then tangent gonion mandibular line, then there is rickets superimposition, and so on. So for different cases, different measurements are created. What I can do is also I can add also an image. For example, this image, and I will put a point here on the top of the nose, save this and return and create again point and rotation. I will not use the calibration because this image is not calibrated, and define elements, pronasale and first point, assemble it, and now I just grab this corner and place the image here. When I'm done, I press done, and I can play now with different viewing options. One thing is perhaps I would like to remove all the points. Then I would like to remove all the measurements, and then I would like to except the ones that were created inside the assembly. Then I would like to perhaps remove all the lines. So what we have here is only view of the photography and the tissue below, but of course we can say, okay, I don't want to have this, I don't want to have it visible, and I only have here now the first tracing. I can create it the image a little transparent, So I can play with that, and when I save it, several things are stored along with the image. So if I take a look at the documents here, on the superimposition, I have here Selanasion superimposition. Then I'm interested in different things, different superimpositions. Now, one last but not least thing would be analysis type creation. There are hundreds of faculties around the world, and each uses different analysis type. Even some orthodontists use different analysis types for their work, and they either want to enrich or reduce number of measurements, and here is a perfect tool to do that. We can do it either from scratch, from existing analysis, or from predefined elements library. What I'm going to show you is how to create it that geometry from scratch. I'm creating a new. I'm going to give a name. If I select this, then it will create a copy. So what I only need is scratch. I'm going to choose a phantom. It can be lateral PA, it can be clay, it can be left or right sided, it can be whole skull. It depends what you want. Now I'm going to add a point here, which is called Sela Turcica, and here is given a name. I'm going to just say S, and then a point here, it's N, another point here, it's A, and a point here, it's B. And now I'm interested for the difference in angle between Selanasion A and B, and I'm going to create some planes here between S and N. Another plane, we are on focused on N now because it changed the color to A, and here from N to B. Now I want to know what is the angle between these two. If A is on the left side or on the right side, it has different values. So it could be minus is on that side, negative is on that side, and the positive will be on the right side. Now I'm going to create an angle measurement between this and this, which is going to be S and B, and another angle measurement between this and this. I'm going to put it on that side, which is S and A. So if I take a look at the model tree, I have here several points, several planes, and two measurements. And the difference between S and A and S and B is exactly A and B angle. So I'm going to create a function S and A minus S and B is A and B, and the measurement unit is in degrees. And I got now a new element, measurement element. Now I'm going to create another measurement, which is called width appraisal, and is a distance between the projections of A point and B point to the occlusion plane. So let's create an occlusion plane, and the distance between these perpendicular projections is exactly width, which again could be positive or negative. So I'm going to need a little workaround here, how determine whether it's positive or negative. I'm going to create a plane which is perpendicular to this plane and going through Sela Turcica or some other point, whatever. And I'm going to create a distance between A and that plane, which is going to be with A, and another distance between B and that auxiliary plane, which is WB. And again, the function WA minus WB will give us exactly the value of width, which is going to be in millimeters, and I'm going to confirm that. Now I have here several elements. Two of them are auxiliary, and I actually don't need them, and I'm going to hide to clean up this mess here. I'm going to hide these elements, perhaps hide the planes, and I will get exactly what I need for tracing the radiograph and determine SNA, SNBA, and BAN width. So I'd like to put this to a certain layer, which I call analysis layer, and this is an option. So all those elements are going to be put at the same time to analysis. And what is on report layer I can determine later. So now it's nothing. Now I'd like to have, for example, these planes, perhaps occlusion plane, and I will put that again to one of existing layers, and it's going to be a report layer. So what I have now, there are two layers: analysis layer, which I'm going to use for creating analysis, and a report layer, which will be seen when I create a report. Now those measurements that are here are not aware of its standard values, so I'm going to add some standard values and link them to already created measurements. So I have here measurements, and what I have here is a table which I can add different patient types, child with, for example, mixed dentition, or deciduous teeth, or adult teeth, or whatever, and I can add different measurements into a table. What I'm going to do is I'm going to import an Excel file, and it did that to me. So I have here different measurements. For example, SNA with mixed dentition is 80 and standard deviation is 4. With adult it is 82.2. So they are put inside, and I just put this together. So it's SNA, SNB, A and B, and widths, they are put together. When they are the same, then the row from that table will fit. And then I say OK. Now I'm going to create a page for the report. I'm going to add, for example, group 1 and group 2. These groups are usually vertical relation or sagittal relations or delta relations grouped together. And I'm going to put SNB, SNA, and B here, and widths into this group. If I create a preview, it is something like that. So I will have here an image. This is a report layer. Here what I have is a table with group 1, group 2, and the measurements which are positioned into certain groups. I'm happy with that. And next thing that I would like to do is is add some superimposition links. So I'm going to say Cela Nasion link. I'm going to choose Cela and Nasion, and will not use calibration. And we can add a report. For example, there will be a report layer automatically added without X-ray when dragging one superimposition over another. So I am actually building this analysis type according to my needs, and I'm going to use it later several times, and it will automate a lot of things for me, including the reports, auto reports, which can be added here, or Excel file, or whatever I want to define in advance. One thing that I do now is I'm going to save this, and now I would like to go to the documents and show you how a document, I makes that like this, how a document or patient can be created out of DICOM file. So I'm going to the patient, and I'm going to add new from file, and I have here a demo, and this is a demo DICOM with some data inside, and I'm going to use that DICOM data so that I don't need to enter the name, family name, date of birth, and so on. It's lateral X-ray, and I'm not going to go to analysis module at once. I'm just going to create a patient out of it. So we have a patient. The name is PlanMeca Demo Images, and the patient is 8 years old, although it's obvious that it's not. What is wrong with that image is that when I create an analysis out of this, you can see that that analysis is, the image is very white. So it's very difficult to use it for defining certain points. I'm going to edit that and make it a little bit smaller so that it fits inside the screen. It's there. Okay. I'll make this a little bit more dark. So it's dark now, but I'm missing the nose. So I'm going to choose here region of interest and apply soft tissue, and I get the nose back. If I'm satisfied with that image, then fine. Otherwise, we can repeat the process. So define the gray level again, define region of interest again, and apply soft tissue. We can play with that, and when I save that, you can see this new view of that image, and I can change analysis type. Oh, it's somewhere there. It's a problem with that because it's smaller now. Okay, so what I did, I don't know what I did. It's behind. So let's say to this one, this is the analysis that I have already created. So I will place I can do the calibration from here to, for example, here it's 40 millimeters. Then I'm done with that, and I can make a print out of that. So you can see that there is an image, there is a report, and here are certain values from the analysis that I have already created. So that is in brief everything. I hope that you got impression. In the future I'm preparing several small snippet movies which explain functionalities, and then you can download them and have a better view. Until then, dear Pradeep, you are free to ask. I'm on the mail almost every day, so I'll be happy to answer any of your questions. So thank you very much, and hope to hear from you soon.